Hello children, welcome to Math Park. Today we are going to solve exercise 24 part 2. In this we are going to solve question number 11 to 20. And so after going through, if you like it, please share with your friends. And if you are new to the channel, please subscribe. We start with question number 11. In the given figure, AB and EC are parallel. You can look at these arrows. AB and EC are parallel to each other. Sides AD and BC are 2 centimeter each and they are perpendicular. 2 centimeter each and they are perpendicular to AB. This is a right angle. Angle AED is 60 degree and angle ACD is 45. Calculate AB. Now AB is equal to DC. AB is equal to DC because it is a rectangle and opposite sides are equal. So for that we will consider this triangle. So we have in a triangle ADC tan 45 is equal to opposite is AD upon adjacent is DC. Tan 45 is 1. AD is 2 upon DC. So you get DC is equal to 2 centimeter. Since DC, this is DC is equal to 2 centimeter and DC and AB are equal. So therefore you get AB is equal to, AB is equal to 2 centimeter. So AB is 2 centimeter. We did with the first part. Now let us start with the second part, that is AC. For AC, again, we will be using the same triangle. So in this same triangle ADC, we will be now using opposite and hypotenuse. AC is an hypotenuse because this is a right angle. So we have sine 45 is equal to opposite is AD upon hypotenuse is AC. Sine 45 is 1 upon root 2 is equal to 2 upon AC. So AC moves here is equal to 2 into root 2, where root 2 is 1.41, multiply 2 1s are 2, 2 4s are 8, 2 1s are 2, 2.82 centimeter, 2.82 centimeter is your AC. Now we have to find AE. So for AE, we'll consider this triangle. So we have in triangle ADE, this is 60 degree and we know the opposite and we need to calculate the hypotenuse which is AE. So we will using opposite and hypotenuse, we will use the sine 60 is opposite is AD upon hypotenuse is AE. Sine 60 is root 3 by 2 is equal to AD is 2 and AE is what we need to calculate. So cross multiply, AE goes here, 2 2s are 4. So 4 upon root 3, rationalize it, multiplying by root 3, dividing by root 3, you get 4 root 3 upon 3. Put the value of root 3 as 1.732. 4 multiplied by 1.732 and then dividing by 3. So you get this as 2 point. This is 2.309, which we round up to 2 decimal figures. This is 2.31 centimeter is your 2.31 centimeter is your AB. Got it? Moving to question number 12. In the given figure, angle B is 60 degree. You have AB is equal to 16 centimeter. BC is 23. This BC is 23 centimeter. You have to calculate BE. Now to calculate BE, we can use the triangle ABE. So in triangle ABE, hypotenuse is given and opposite and adjacent are not known. So we have to find B, which is adjacent. So adjacent upon hypotenuse, we'll use cos ratio. So we have cos 60 is equal to BE upon AB. So cos 60 is half is equal to BE upon AB is 16. 2 1s are 2 8s are. So you get BE is equal to 8 centimeter. So you got BE as 8 centimeter. Now we have to find AC. For finding AC, no angle is known over here. Now this we got 8. So let us 23 minus 8. This EC we get 15 centimeter. And let us find AE using trigonometry for this triangle ABE. So for same triangle, now we have to find the opposite and we know the hypotenuse is given. So let us use the sine ratio. So we have sine 60 is equal to opposite is AE upon hypotenuse is AB. Sine 60 is root 3 by 2 is AE upon AB is 16. 2 1s are 2 8s are. So you get AE is equal to 8 root 3. You got AE. This AE is 8 root 3. Now let us use Pythagoras theorem for this. So using Pythagoras theorem for triangle ABC, AC square is equal to AE square plus EC square. So AE is 8 root 3 square plus EC is 15 square. 8 square is 64 and 60 root 3 square is 3. So 64 multiplied by 3 you get 192 and 15 square is 225. So 192 plus 225, we get this as 417. Now you got AC square is equal to 417. So AC is equal to root of 417. So let us do root of 417 by long division method. So we pair it, 4 is left. So we have 2 2s are 4. Let me change the color of the pen here. So we have 2 2s are 4, 2 2s are 4, 4 minus 4 is 0, plus 2, so you get here 4. Bring this 17 down, so zeros are 0, so you get here 17 down. Put up decimal and take a pair of zeros, plus 0, so 40 comes here. Since we are bringing this 0 0 down now here, and 4 4s are 16. So let us see, 4 4s are, you have to think that 400 point and then 404, 404 multiplied by 4, 4 4s are 16 and again 4 4s are 16. You get 1616 and add 4 here. You get 408. Subtract 4, carry 1, 84. Again, take a pair of zeros, bring the zeros down there. So no place. So it is going to be 8400 here. And we have to put a number against this. So 404, let us try 408, 2 times 2. 2 2s are 4, 2 8s are 16, carry 1. You get 2 8 2 0 1. So 2 4s are 8 again, 8 1 8 4. So you get 4082 times 2. You are getting 8184. We can leave it here when we have got the answer up to 2 decimal places. So 20.42 centimeter is your AC. So your AC is 20.42 centimeter. Got it? See, so you are given a triangle BC, AD and AC. This is 12. This is 90 degree. So if this is 30, this angle is going to be 60 because the sum of the three angles of a triangle is 180 degree. So you got this 60. Now to find BC, we need to find BC, we will be using a right triangle ABC. So where opposite and adjacent. So we have in triangle ABC, we have tan 60 is equal to opposite is BC upon adjacent is AB. So tan 60 is root 3 is equal to BC upon 12. So you get BC is equal to 12 root 3. BC is equal to 12 root 3. Put the value of root 3 as 1.732. So 1.732 multiplied by 12, you get this as 20.784, 20.784. Rounding to 2 decimal places, we get just 20.79 centimeter is our BC. So we got BC as 20.79 centimeter. Now let us find the other part. So we have AD now. For finding AD, we will be using again the triangle ABC where it is AD is the adjacent side and this is the hypotenuse. This is the hypotenuse. This is 90 degrees. So this is hypotenuse and this is adjacent side to AD, adjacent. So we will be using in this triangle, in triangle ABD, we will use adjacent and hypotenuse. So we'll use cos 60 is equal to adjacent side, which is AD upon hypotenuse is 12. Cos 60 is a half is equal to AD by 12. 2 ones are 2 6s are. So you get AD is equal to 6 centimeter. We got AD as 6 centimeter. Now to find AC. For finding AC, we need to find CD now. Only then we will be able to find. So we have already calculated BC was 12 root 3. I'm going to keep it as 12 root 3 instead of taking 20 0.79. So this was 12 root 3. And this is hypotenuse, and this is the adjacent side to 30 degree. This is the adjacent side, and this is the hypotenuse. So in triangle BDC, we use cos 30 is adjacent side, which is CD, upon hypotenuse, which is BC. Cos 30 is root 3 by 2. CD is what we have to find out, and BC is 12 root 3. So you get CD is equal to root 3 into 12 root 3 upon 2. So we just shifted this 12 root 3 over here. So 2 ones are and 2 6 are. Root 3 into root 3 is 3. So 6 times 3, this is 18 centimeter is your CD. And now you have to find AC. So you have AC is equal to CD plus AD. CD is 18 and AD is 6. So 18 plus 6, 24 centimeter is your AC. So you got AC as 24 centimeter. Got it? Question number 14. In a right angled triangle ABC, angle B is 90 degrees. So let us take a right triangle where angle B is 90 degree. This is ABC is a right triangle where angle B 90 degree. Find the magnitude of angle A if AB is 3 times of BC. So let us take BC as X and AB is root 3 times of BC. That is root 3 times X. And then you have to find angle A. So we are doing the first part. So for finding angle A, this is opposite and adjacent. So opposite and adjacent, we will be using the tan ratio. So we have tan A is opposite, which is BC, upon adjacent is AB. So BC is X and adjacent is root 3X. X and X got cancelled. This is 1 upon root 3. And we know that tan 30 is equal to 1 by root 3. So this implies A is equal to 30 degree. We got comparing these two equations, you get A is equal to 30 degree. Now for the second part, let us take this triangle again. So B is a right angle. So this is your ABC. This is your ABC is a right triangle. Now they say that BC is root 3 times of AB. So let us take AB as y, then BC is root 3y. So if I have to find angle A again, so we will be using tan A is equal to opposite, which is root 3y, upon adjacent, which is y, so which we get as root 3. And we know that tan 60 is equal to root 3. This implies A is equal to 60 degree. Got it? So we did with question number 14. Moving to question number 15. A ladder is placed against a vertical tower. A ladder is placed against a vertical tower. So this is a ladder. This is your ladder. And this is the vertical tower. If the ladder makes an angle 30 degree with the ground, so this angle is 30 degree with the ground, and reaches up to the height of 15 meter of the tower. So 15 meter of the tower, find the length of the ladder. Find the length of, it is reaching at the height of 15 meter of the tower, the ladder. Then find the length of the ladder. So with respect to 30, this is the hypotenuse. This is the hypotenuse. If I take this as angle ABC, always a right triangle, this is the ladder is the hypotenuse. So we will be using now sine 30. So sine 30 is equal to opposite, that is AB upon AC, which is the hypotenuse. Sine 30 is half is equal to AB is 15 upon AC. So take AC over here. 2 comes this side. 15 times 2, which is 30 meter. 30 meter is the length of the ladder. So the length of the ladder is 30 meter. Got it? Attached to a 100-meter long string. Find the greatest height reached by the kite when the string makes an angle of 60 degree with the level of a ground. So we need to draw the figure here. So figure is always a right triangle and the length of the string is the hypotenuse over here. So the length of the string is your hypotenuse. Let us name this triangle as A, B and C. So length of the string is 100 meter and the string makes angle 60 degree with the ground. So this is the 60 degree angle. Find the greatest height by the kite when the string makes an angle 60 degree. So this is the height and this is your kite. So your kite is over here. This is your kite flying over here. Okay. And then you have to find the height of the at which the kite is flying. So opposite and hypotenuse. So again, we will be using sine 60. Sine 60 is AB upon hypotenuse is AC. Sine 60 is root 3 by 2 is equal to AB, which is 100. Sorry, AB, which is to be calculated, and AC is 100. So 2 ones are and 2 50s are. So you get AB is equal to 50 root 3. Root 3 is 1.732. So 50 into 1.732. So let us multiply 50 times 1.732. You get this as 86.6 meter is the height at which the kite is flying. The maximum height reached when the angle made is 60 degree. Got it? Moving to question number 17. Find AB and BC if. So for the first figure, let us start. We have to find AB and AC if the given figure, the given angles are given to you. So this is 20 meter. You don't know, for finding this is 45 degree and this is 45 degree. So we don't know what is the value of BC. So let us take the BC to be X and AB to be, since this is 45 degree and this is 45 degree, so it becomes an isosceles triangle. So you get AB and BC both become X and X. And now we have to find BC will be calculating later. First, let us use 30 degree. For 30 degree, opposite and adjacent. So opposite and adjacent for in triangle ABD now, we have tan 30. Tan 30 is equal to opposite, which is X upon adjacent, which is X plus 20. So tan 30 is 1 upon root 3 is equal to X upon X plus 20. So you get X plus 20 is equal to X root 3. So let us solve this further. Take the X terms on one side. So you get X root 3 minus X is equal to 20. Take X common. You get root 3 minus 1 is equal to 20. So value of root 3 is 1.732 minus 1 is equal to 20. So you get X is equal to 20 upon 1.732 minus 1. It is 0.732. So let us simplify this. So multiplying by 1000 and 1000. So 20 divided by 0.732. So you'll have to remove the decimal. So we multiply by 1000 and 1000. So we get this as uh, 20,000 divided by 732. So let us do 20,000 divided by 732. You get this as 27. So you get X is equal to 27.32 centimeter. So that is how you get BC is equal to 27.32 centimeter. We calculated BC and then and AB and BC, and both AB and BC are equal because this is a 45 degrees. Also you get AB is equal to 27.32 centimeter. Again, we have to find AB and BC. So let us take BC to be X. Now for triangle, in triangle ABD, let us use tan 30, and tan 30 is opposite, that is AB upon BC. So tan 30 is 1 upon root 3. So AB, this is 1 upon root 3, and 1 upon root 3 is tan 30, which is equal to AB upon BC is 20 plus X. So this is how you get AB is equal to 20 plus X upon root 3. Let this be the first part. Now let us use in triangle ABC. So in triangle ABC, you have a tan 60 is equal to AB upon BC, which is root 3. Tan 60 is root 3, and A, which is AB upon BC is uh, X. So you get AB is equal to root 3x. This is our second part. So from 1 and 2, since we have two values of AB, so we get from 1 and 2, you get 20 plus 20 say root 3x is equal to 20 plus x upon root 3. So root 3 goes here. So root 3 into root 3, we get 3x is equal to 20 plus x. Taking this x here, 3x minus x is equal to 20. 2x is equal to 20. So x is equal to 10. So what is x? So you got BC is equal to 10 centimeter. So we now found BC is equal to 10 centimeter. Let us put it in the equation number. Let us put it in this equation number 2 to find AB. So AB is equal to x root 3. So AB is equal to root 3 into x ka value we have got 10. So which is 10 root 3. The root 3 value is 1.732 multiplying by 10. This becomes 17.32 centimeter. So this is how we got AB as 17.32 centimeter and BC as 10 centimeter. So in the third one, again, like the second one, we'll get two values of AB. So let us take the BC to be X. Let us take the BC to be X. So we use tan 45 now, opposite and adjacent. So we will be using in triangle ABD. Have tan 45 is equal to AB upon BD. Tan 45 is 1 is equal to AB upon BD is 20 plus X. So you get AB is equal to 20 plus X. Let this be equation number 1. Now let us take the triangle ABC. So in triangle ABC, we have tan 60 is equal to AB upon BC. Tan 60 is root 3. So we get tan 60 is root 3, which is AB upon BC. AB is 20 plus X upon BC is X. From this equation number 1, we substituted the value of AB as 20 plus X. So we can say here from 1. So X moves here. We get X root 3 is equal to 20 plus X. So taking the X on the other side, X root 3 minus X is equal to 20. X taken common, we have root 3 minus 1 is equal to 20. So root 3 is 1.732. 1.732 minus 1. So we get X in bracket 1.732 minus 1 is equal to 20. Let us do it here. So we get X is equal to 20 divided by 1 minus 1.732 minus 1 is 0.732. So multiplying by 1000 to remove the decimal down, we get this as 20,000. 20,000 divided by 732. Simplify this, keep on dividing by 2 and you get finally reach this as 27.32 centimeter is your X, which is BC. So you got BC as 27.32 centimeter. Now to find AB, now let us go to equation number 1 back. So AB is equal to 20 plus 27.32, which is 47.32 centimeter is your AB. This is how we have done with question number 17. If AB is 150, AB is 150 meter and angle P is 30 degree and angle Q is 45. We have to find PQ. So that is this distance we have to calculate. So let us find BQ first. So for triangle, that is in a triangle ABQ, we have tan 45 is equal to AB upon BQ. So tan 45 is 1 and AB is 150. So 150, if this is BQ, AB is equal to 150. This BQ goes here. So you get BQ is equal to 150. So remember, if it is a right angle, one angle is 45. This is going to be isosceles. This is how we got 150 meter as BQ. Now to find PQ, we need to find a PB. So we will be now using a triangle APB. So in triangle APB, opposite and adjacent. So we will be again using tan 30 is opposite is AB upon adjacent is PB. So tan 30 is 1 upon root 3. AB is 150 upon PB. Cross multiply, PB goes here. So PB is equal to 150 root 3. Now we are asked to find PQ. So you get PQ is equal to PB plus BQ. So that is 150 root 3 plus 150. If you take 150 common, you get root 3 plus 1. So 150 in bracket root 3 is 1.732 plus 1. So which is 150 multiplied by 2.732. So let us do 150 multiplied by 2.732. 150 multiplied by 2.732. You get this as 409.8 sorry, it is a meters. Yeah, it is meters. So you get length of PQ as 409.8 meters. Let's do the second part now. Let's do the second part. Again, you have to find PQ. This is 45 degree given. And you have given AB as 150 meters. So using tan 45. So let us use tan 45 is equal to, this is for triangle ABQ is opposite, that is AB upon BQ. So which is 1. So AB is 150. Why I'm writing BB? AB is 150 is equal to BQ goes here. So BQ is equal to 150 meters you got. Now you have to find BP. So let us use for triangle. In triangle APB, tan 30 is equal to opposite is AB upon adjacent is BP. So tan 30 is AB is 150 upon this is BP is 150 plus PQ, which is equal to 1 upon root 3. So PQ is what we have to calculate, so that we'll be able to find this. So let us substitute, let us calculate this further. So you get 150 plus PQ is equal to 150 root 3. So you get PQ is equal to 150 root 3 minus 150. Taking 150 common, you get root 3 minus 1. So 150 into root 3 is 1.732 minus 1, which is 150 multiplied by 0.732 is your PQ. So let us do this here. So you get PQ is equal to 150 multiplied by 0.732. So you get PQ is equal to 109.8 meters. Got it? Easy that. So we did with question number 18. Moving to question number 19. Given tan x is equal to 5 by 12 and tan y is equal to 3 by 4. And we have to find CD. So AB is given to you as 48 meter. And let us take this as say A and let us take this as say B, BC as B. So we have tan x is equal to 5 by 12 and which is equal to opposite, which is A upon adjacent is B, AC, which is 48 plus B. So we get, let us simplify this. You get 5 in bracket 48 plus B is equal to 12A. Multiplied 5 multiplied by 48, 8 5s are 44, 5 4s are 20 plus 4, 24, 240 plus 5B is equal to 12A. So, or we get 240 plus 5B upon 12 is equal to A. Okay, this part we have done. Now, let us use tan Y. So, we have tan Y, tan y is equal to, if I take tan y, we are taking this triangle, which is A upon B, which is equal to 3 by 4. So you get A is equal to B goes over here. So B is equal to 3A. So we get 4A is equal to 3B, or you get B is equal to 4A upon 3. Let us put this value in this equation, value of B over here. So that we get the value of A, which is CD to be calculated. So putting the value, you get 240 plus 5B, that is 5 in bracket 4A upon 3 upon 12 is equal to A. So solve this further. So we get 240 plus 5 fours are 20a upon 3 is equal to 12a. This a goes over here. So we get, take the terms with a on one side. So we get 12a minus 20a upon 3 is equal to 240. So taking the LCM, 3 12s are 36a minus 20a upon 3. So this upon 3 is equal to 240. So 36 minus 20 is 16. A upon 3 is equal to 240. So you get A is equal to 240 into 3 upon 16. Let us divide this, divisible by 4. So we have 4 4s are 16, 4 60s are 4 1s are 4, 4 15s are 60, and A is equal to 15 times 3, which is 45. This is how you get CD is equal to 45 meters. Got it? Last question of today's video. The perimeter of a rhombus is 96 and the obtuse angle is 120. So if this obtuse angle is 120 and perimeter is given to you as 96. So if the perimeter is 96, all the sides of rhombus are equal. So the side of a rhombus is equal to 96 divided by 4. 4 2s are 8 and 4 4s are 16. We get 24 centimeter is the side of a rhombus. We get the side of a rhombus as 24 centimeter. And we know that the diagonals of rhombus bisect each other at right angles and also bisect the angle at vertex. So if the obtuse angle is 120, then you will have this angle as 60 and 60. This they also bisect. So you get this angle as 60 and 60. Now this is a right angle, so this angle will be 30 degrees. Now we know that the diagonals bisect each other. So let us take this diagonal a bisecting. Let us take this as x and x. Let us take this as y and y. Okay. Now let us start using the trigonometry for this triangle A. Let us say the diagonals are intersecting at O. So for in triangle AOB, you are given the hypotenuse is known, okay, and the angles 30 and 60 are known because this is a right triangle, so this is going to be 60, this is 30, but we will be using the angle 120 which is given, so each angle is 60. So if I use 60-degree angle and you know the hypotenuse, and if I have to find the opposite, we will be using sine 60. So sine 60 is equal to opposite, which is x, upon hypotenuse is 24. Sine 60 is root 3 by 2 is equal to x upon 24. 2 ones are and 2 12s are. So you get x is equal to 12 root 3. We got x as 12 root 3. So the diagonal AC is 2 times 12 root 3, which is equal to 24 root 3. Since the diagonals are bisecting, let us put the value of root 3 as 1.732. So we have 24 into 1.732. Let us multiply 24 into 1.732. 1.732. You get this as 41.568. You get this as 40. You get AC, diagonal AC, you get this as 41.568. Rounding to two decimal places, we get as 41.57 centimeter is your diagonal AC. So one diagonal we calculated. Now let us find the another diagonal. Another diagonal, for that we will be considering the same triangle. So in the same triangle AOB, now adjacent and hypotenuse. So adjacent is y. So adjacent and hypotenuse will use cos 60. Cos 60 adjacent is y and hypotenuse is 24. So cos 60 is 1 upon 2 is equal to y upon 24. So you get, so let us 2 ones are and 2 12s are. So we get y is equal to 12. And then the diagonals bisect. So you have diagonal BD is equal to 2y, that is 2 times 12, which is 24 centimeter. So thus we have done with the entire exercise 24, children. So if you like it, please share with your friends. And if you are new to the channel, please subscribe. Thank you for watching. Have a good day.